Spanning Tree Protocol or STP. In this video I'm going to talk about again STP, but now we will learn about the STP protection mechanism. You know that in previous videos we have learned about the STP port fast and also STP BPDU guard. Here we are learning about the other protection mechanism that we have in the Spanning Tree Protocol. The first feature that I'm going to talk about that is root guard. It is an easy feature and we can use it easily, and it is so useful. What is the meaning of Spanning Tree root guard feature? Means a guard for root bridge. It is so easy. Assume that here we have switch 1, switch 2, switch 3, switch 4 and switch 5, and about the MAC address, the MAC address of the switch 1 is lowest MAC address in this scenario, okay, and assume that the switch 1 is our root bridge. This is our root bridge, okay, or root switch. And also for example, we have configured one switch as the secondary root bridge. For example, the switch 2 is our secondary root bridge, and we don't want to other switch can be take the role of the root bridge. Yes, I know that you can decrease the you can increase the priority of the switch 3, switch 4 and switch 5. It is possible, but we should ensure that always the switch 1 is the root bridge, and when the switch 1 is not available, the switch 2 is our root bridge. How we can control the for example root bridge placement switch 1 and switch 2 with priority? But it is possible, okay, that switch 3's for example priority is configuring with lower value than the root bridge. Assume that here we have configured Spanning Tree VLAN ID root primary in the switch 1. Because of that, in switch 1 we have priority of 24,576, and also here we have configured on the switch 2 Spanning Tree VLAN 1 root secondary. Because of that, the priority of this switch now is 28,672. okay, assume that one administrator or one, for example, attacker is configuring the switch 3, switch 4 or switch 5 with lower priority, for example priority 0. What does it mean? It means that now the switch 1 is the root bridge, or switch 4 priority 0, switch 5 priority 0. Actually, if you configure these priority values, okay, in the switch 3 or switch 4 or switch 5 or other switches, okay, you will see that the active topology is changing. How we can prevent to change of the root bridge? Here we have a feature, we call it STP root guard. If you want to use the root guard, okay, you can enable it on one interface. For example, assume that we are configuring the root guard feature, okay, on this interface. But what is the function of the root guard when you are configuring the root guard on one interface? Let me to explain it with one simple example. For example, here in the switch 4 we have configured, okay, the priority with 0 value. Okay, what does it mean? It means that now switch 4 assumes itself as the root bridge. Okay, because of that, it is starting to send BPDUs or superior BPDU. Here in the BPDU we have the bridge ID equal to the priority of 0 colon the MAC of switch 4. Okay, you know it. After that, in normal scenario, without root guard, the switch 3 should accept this superior BPDU. This is a superior BPDU, and after that the switch 2 will be the root bridge. Okay, the switch 4 is the root bridge, and the other switch should accept the root bridge placement in switch 4. But when you have root guard, okay, on one interface, and on this interface we are receiving BPDU or superior BPDU, okay, the switch 2 doesn't accept it, and this port, okay, converted to one specific type of port. We call it broken port. Okay, this port now are broken port. The state of this, the port state of this port is broken. Okay, and actually this port is blocked. We call it inconsistent port. Okay, because we don't accept to see here the superior BPDU. Also, we should configure the root card on all of the interfaces that you don't want to see on those interfaces, the root bridge. For example, on the gigabit 03, we don't, of the switch 3, we don't expect to see the for example, superior BPDU. Because of that, we should configure this feature here. Actually, after the configuration of root card, if we see superior BPDU on these two ports, we shouldn't accept it, and actually these ports are going to the state of broken, and this means that the switch has detected a configuration or an operational problem on a port that can have major effects. The port discards packets as long as the problem continues to exist. It is so easy. Let me to show you. First, this is our scenario. Let me to show you the default status. After that, we can talk about the effect of root card. Actually, I'm going to show you first the scenario with the switch 1, switch 2, switch 3, switch 4, and switch 4 with default behavior. And then I'm going to show you what is happening when you are changing the priority of switch 4 to 0. And after that, I'm going to show you what is the effect of root card. Alright, this is our scenario for root card. First, let me to show you the default status in the switch 1. Show a spanning tree can show us now we have this switch as the root bridge, and two ports, gigabit 01 and gigabit 02, both of them are designated ports. It's okay. In the switch 2, okay, let me to show you the status. Show a spanning tree. This switch, okay, has one root port. Gigabit 01 is the root port, and gigabit 02 and gigabit 03, both of them are designated ports. And then in the switch tree, host name is switch 3. Show a spanning tree can show us we have here gigabit 01 as the root port, and gigabit 02 as the alternate port, and gigabit 03 as the designated port. It's okay. And finally, in the switch 4, okay, host name is the switch 4. Let me to show you the status. Show a spanning tree. As you can see here, the port 1 is the root port, and the port 2 and 3, both of them are designated ports. In the switch 5, this is the switch 5, host name switch 5. Show a spanning tree can show us we have one root port and two alternate ports. Okay, this is the default status. Now I'm going to change the priority of switch 4 to 0. Okay, conf spanning tree, configure terminal spanning tree, VLAN 1 priority 0. Now this is our new root bridge. Do show a spanning tree. As you can see, this is our new root bridge. All of the ports are using the designated role. It is so easy to understand. And now the switch 1, look at here, this is the switch 1. This is now this switch is not our root bridge. As you can see here, we have one root port, designated port, and as you know, all of the active topology is changing. Let me to change the priority of switch 4 to default status. No spanning tree, VLAN 1 priority 0. Do show a spanning tree. Now the priority of this switch is 32,768, and in the switch 1 now we have again the root bridge. Look at here, after some second we expect to see that switch 1 is our root bridge again. Here in the switch 2, let me to show you the status. Show a spanning tree. In the switch 2, now as you can see, the port 1 is the root port. It means that the switch 1 is our root bridge. Look at here, this is the switch 1. Yes, this bridge is the root. Now everything is working like the default status. Now I'm going to enable the spanning tree root card feature on the port 3 of switch 2 and on the port 3 of switch 3. Actually, on all of the ports that we don't expect to see root bridge, we should enable this feature. On the switch 2 interface, here conf interface gigabit 03 spanning tree guard root. That's it. Here we don't have any other option. It is so easy. Also on the switch 3's gigabit 02, look at here, root card enabled on port gigabit 03. This is the switch 2's gigabit 03 interface. And then in the switch 3, let me to configure interface gigabit 03 spanning tree guard root. That's it. Now let me to show you the status of switch 2. Switch 2's interface gigabit 03. Show a spanning tree. Okay, show a spanning tree interface gigabit 03. As you can see on this interface, now we have this information. You can use detailed keyword. Here we have root card is enabled on the port. Also on the port 3 of switch 3, show a spanning tree interface gigabit 03 detail. As you can see here, root card is enabled on these ports. Now, again, I'm going to show you what is happening when we are changing the priority of switch 4 to 0. This is switch 4, spanning tree, VLAN 1, priority